Hey everybody, it's Mr. Carr again. Today we're going to be talking about 4-5 day one. We're talking about a new method of dealing with our quadratics called completing the square. To help us understand that a little bit, let's talk about this example right here. Find the value of c that makes x squared plus 12x plus c a perfect square. Then write the trinomial as a perfect square. Remember, as a perfect square, what that means is it's going to look something like this. It'll be x plus blank squared. So that means I should be able to factor it and should factor into the same things like x plus 3, x plus 3. Well, in order to get that, to find the value of c, we can kind of do this right here, where it makes the quadratic a perfect square. We take 1/2 of the linear coefficient, but then square that value. The linear coefficient is b. So the c that's going to help with this is going to look like this. If I take 1/2 of b, and then I square that value. So in this case, it's 12. So if I do that, I can say that that is 1/2 of 12, and then I square that. So that's going to be 1/2 of 12 is 6. So I take 6 squared to get 36. So according to that, then I should be able to pick a c value like that, where it looks like this: x squared plus 12x plus 36. If I go through my factoring process now, just to confirm I did get the right thing, we go right here, we need x and x. What multiplies the 36 adds to 12. It's a positive 6 and a positive 6. Well, that can come together like this: x plus 6 squared. So we're good. Okay. So that is the value that makes that a perfect square. And that's what we mean by perfect square. It needs to be in this format of x plus, I should say this, x plus or minus some number squared. Okay. So how does that work for something like this? We're going to solve this equation by completing the square. And this is the process. We're going to go through step by step on how to do this example right here. This is like a pretty straightforward one. X squared plus 4x minus 20 equals 0. Okay. Always try to factor first. If there is like a greatest common factor, see if you can take one out. Okay. After that, you're going to move the constant term to the other side of the equation and add a blank to each side. So it looks something like this. So I'll have x squared plus 4x plus blank equals 20 plus blank, because I just added the 20 here to both sides. But I'm leaving that blank there on purpose, because just like we did on the previous problem, we want to do the 1/2 the linear coefficient, or b squared in this case. So I'm going to do that. I'm going to take 4. So we're going to take 1/2 of 4, gives me 2. And I'm also going to square that 2 to get back to 4. Okay. So since I'm going to add a 4 here, I'm also going to add 4 to the other side. That's the key part about this too, because whenever I do the left side for addition, got to do the same thing to the other side. So I'm going to simplify this now. I'm going to factor the left side. So this, because of the pattern I did, this right here will factor into x plus 2 squared. Okay, it's kind of like we can take the square root of this number by following this pattern. But again, what multiplies to 4 adds to 4? It's 2 and 2. That's going to equal to 24. Solve by using the square root property. I mentioned this before. Square root property is whenever I have something squared is equal to some value, I'm able to take the square root of both sides. But you have to take the positive and negative square root. So since this is x plus 2 squared, we can take the square root here and the plus or minus square root of 24. 24 is not a perfect square. So that means I'm going to break that down. So over here on the side, I'll just do this real fast. That is the same as 4 times 6. So I can square both of those. So it turns into 2 square root of 6. So on the right side, it'll be plus or minus 2 square root of 6. On the left side, by taking the square root of all of this, that's going to get rid of this right here. So it just turns into x plus 2. My final step for solving, I want to get x by itself. So we're going to subtract 2 from both sides here. Okay, so I'm going to get x equals negative 2 plus or minus 2 square root of 6. So I cannot combine any further. This is my exact answer. Okay, I'm going to go ahead and add a little bit extra here, because I do want to talk very quickly about right there. What happens if I have x equals negative 2 plus 2 root 6. In a calculator, if you solve this out, you can get an approximate answer. These are called irrational answers. They're irrational because this is not a perfect square. You plug the square root of 6 in your calculator, you're going to get a long infinite decimal. What would it be? 2.45, something like that, whatever goes on. So what I'm going to do is I'm actually going to do this in my calculator to get the actual approximate irrational numbers. So I'm going to do it 2 times. -2 plus 2 root 6, -2 minus 2 root 6, because that's what the plus or minus idea means. So we're going to do these both times. So I got -2 plus the square root of 6, oh, sorry, plus 2 times the square root of 6. Okay, so when I do that on the left side, I get a positive 2.899. Okay, on the right side, we do the same thing, but we do subtraction. And I get a negative 6.899. Okay, these are approximate numbers here. So 2 things about today is the idea. One is about the rational solutions, and we get that because of the square root of a number that's not a perfect square. But the main idea is this completing the square process. So one last time, to complete the square, we get the number over the other side. So it leaves this as like my factoring. Then I can take 1/2 the middle term. Right there is 2. 2 squared, oh, time's up. 2 squared is 4. And that gets added to both the left and right side. This will, this now factors into x plus 2 squared. This just goes together as 24. And then we're allowed to do the square root property. So we square both sides. Sometimes you'll get a nice, neat number. Sometimes you'll get imaginary numbers. We'll see in the next lesson. But that's it for today. That's our basics of completing the square there. All right. Take care, everybody.